Yo, what's up guys? So last video I showed you guys this schematic, this layout of my computer or CPU, and this video I'll be showing what it actually looks like in Minecraft. So let's check it out. So this is what my CPU looks like in Minecraft. So as you can see over there, I have my instruction memory. Here I have my 64 bytes of RAM, I have my ALU, and then down here I have my control unit. Now just ignore that, that's a appliance, I guess, for one of my programs. I'll talk about that in a future video. But first, just quick rundown of what everything does. So we have our instruction memory, which right now has a program stored in it, and it's just made of a bunch of these comparator locks. So if I have a byte stored here, right, it's not going to activate the comparator unless I unpower this column, which then will unlock this and send the signal out. Now so the step counter, which I'll show you, keeps track of which one to unlock so that only one is unlocked at a time. And so this way we can kind of go step by step through the program and not everything is activated at once. There's 8 units, I guess, of memory, or instruction memory, each with 32 steps. And so the issue with having 2 outputs in multiple units is that you kind of have to cross the outputs, which causes a lot of delay because of the amount of repeaters I'm using. But eventually it gets through here, and as you can see, these bytes immediately diverge, going to all different parts of the computer. So let me show you this. Let's do the cyan part first. So these 2 bytes of cyan are normally going to the 2 operands. So this is the first operand, this is the second operand. And the bottom one can also go to the step counter. Like I said, it really depends on what the function is. Now, and also the top one can go straight into the RAM. So again, really depends on what the function is. This white part down here goes into the memory, which this is the just the memory address I want to store a value to. Which, as you can see, I have to actually go here. Let me follow it. I actually have to go around because I already have, for the 2 outputs or displaying the operands, I have to do this crossy stuff, and I don't have room for the memory, so I just bring it around here. So just wanted to let you know that still goes into the RAM. It doesn't just go off into the distance just randomly. It just feeds back into the RAM. Now let's check out this step counter here. So the step counter, if I can look at it from above, is really just half of an adder. And so what happens is we mini memory unit, I guess, where it stores whatever the value is, what step it's on. In this case, it's 0, and then it's immediately put through the adder with 1. And as you can see, I just put a redstone block to represent 1 there, and it's constantly adding by 1. So by giving this torch a short pulse, it will open it up briefly and then lock it again. So then it can store whatever's whatever the step is plus 1. And now, as you can see, it stores 1, but now it's immediately showing that the next step is 2. So now I can give another pulse. So we have 2, and it should be 3, 1, 1, and then 1, 0, 0. Oh, that was too fast. There we go. So we have 1, 0, 0, and that's 4. So that's kind of how it counts, and it can go up to, I guess, 1 byte, 255, which accounts for all 256 steps, 0 through 255. Now let's show off my control unit. So as you can see, this is my control unit. So it takes this lime green byte, which I just call it byte 1 or whatever, and goes into a decoder. So after it decodes, it goes up here, and as you can see, 0 is on right now. 0 literally just does nothing. As you can see, there's no torches or anything. It's just like a placeholder. It does nothing. It just stops the program. But then we have like load number, load register. We have jump. We have display. We have some operations. We have input. We have like if statements. And then we have some more logic here. So we have equal to, 1 equal to, greater than, less than. And then these 3 out here are just for future functions I want to add. But as you can see here, whenever one is activated, so if I were to take this line, see it's activated. If there were torches on this, those torches would turn on and then send a signal through and go through the system. But for 0, there's nothing. But for everything else, there is. So I'm not going to activate it right now. I'll show you that in a future video. But it will activate a combination of these lines and go out all over the computer to activate different things. Here we have our operation bits, which, like I said, it's kind of that 4-digit binary number just to save room. And then here I have 4 general purpose outputs, which I have something hooked up to it for now. I'll show you that again in a future video. And then here I have check, which the check is, I did it very similar to how I did it in my previous computer, where I would do a logical operation, and then the check would say, okay, well, if the output of it was a 1, which kind of takes like a Boolean output, so true or false. So if it was output was a 1 or a true, it would do nothing. But if the output was a 0, which would be false, then it would activate jump. So in the check command, I would give it a value or step to jump to if it's false. So then that way I can kind of create if statements where it would skip over a chunk of code if it's false and run it if it's true. But yeah, so I tried to keep this as neat as possible just so I didn't have the same scenario I had with my past computer. So this makes it a lot easier for me because I can kind of bring all the parts of the computer to one area that I can easily control. So the control unit, like I said, is connected to everything else, to all the outputs and inputs. Here we have our RAM, which then goes to another jumble, and then finally we have our outputs here, which goes into ALU. And these are our operation bits, which kind of controls which function to do. Like I said, subtract, add, equal to, all that stuff. It will go through the ALU and then be outputted here, and then immediately come back around and back into the RAM. So this is my really simple CPU. I do want to work on a faster, more complex, more powerful one in the future. But for now, I'll just have a few videos going over what this can do, showing off a few programs I wrote for it, really just Fibonacci sequence stuff, which I just like doing for computers. But yeah, for now, that's about it. Peace.